Walaikum assalam.
How are you, Buddha?
Good, how are you?
So, okay. So we are going to start the hypothesis testing. Oops. Let me bring my pen. Can you see my screen? Ma, can you hear me?
Yeah.
So can you see my screen?
Yeah.
Tomorrow is the Saturday. Will you be available tomorrow anytime?
Maybe
Maybe
like around when?
around 1. Not in the evening?
No, I'm asking you around when.
No, not around 1 exactly. I will be free in the evening tomorrow. So, just a
Like what
second.
time?
What time? Just a second. Let me check. I guess I will be available in evening like 7 to 8 or 8 to 9 for me. No, not 8 to 9, 7 to 8, I guess.
Okay, I'll tell you in a bit.
So today we are going to start the hypothesis testing. This is the last chapter, no?
Yeah.
How's the preparation for the P3?
I started doing papers, but I'm doing more S2 because it's closer.
S2 is on
May 6th.
May 6. Hypothesis testing and errors. Type 1 and type 2. So now first we are going to discuss about the, do you know about the tail test? You know the meaning of the tail tests? Like upper tail test, lower tail test or something like that. Do you have any idea?
Isn't it if it's increased, then it's upper tail?
Mhm. And what is decrease in lower tail? Okay.
Yeah.
But first we are discussing about upper tail test. Okay, when I'm dealing with the upper tail test, na, so there is a very important thing that let's suppose we are going to check any of the particular values, and in this values we have to proceed with this one. Like we are going to check our mean, and we are going to check any expected values, something like that. So let's suppose if it is mean, it is starting from 0 until n over here. Okay, and the important thing is this, like any of the point will be considered that the critical point, and this critical point, they are thinking that your hypothesis means your mean can be lie in this region. Okay, or it can be lie in this region. So this is exactly the hypothesis. For example, if I just go for the normal distribution, and I can tell you from the graph of the normal distribution, so they are exactly checking that the where the mean is exactly lying. Okay, and this is the point over here. So this portion, what they're thinking, it's a lying of critical region, and in this critical region, they may be possible that hypothesis means your mean is lying over here, and your mean is lying over here. So in order to identify this kind of test, we always go for creating the hypothesis. Okay, and what is our hypothesis? Like the critical region or something like that. So this particular region, which is over here from this point to this point, it is exactly 5%, which I'm considering. That is exactly alpha, which is given in the question. And when this portion is considering I'm a critical region, and whatever the claim is, okay, whatever the claim is, let's suppose just think about it. For example, if I am a runner and I'm running uh, 10 kilometer a day, okay, for example, and now I just go to the coach, and I hired a coach for me, and he increased my speed, and now I'm just running almost 15 kilometers. Okay, so now what is exactly I'm doing? I'm testing that when I hired a coach, so my running speed was increased or not. That is exactly look like a hypothesis. Okay, is that clear? Like first I was just getting my null hypothesis is exactly this one. Like the average for per month, what I was getting, that was 10 kilometer per month. Okay, but when I hired a coach, so my alternate hypothesis, now what I'm checking, like my my distance of mean running mean will be greater than 10 kilometers or not. Okay, that is exactly looks like a hypothesis. Is that clear? Are you there, beta? Are you there?
Yeah, it disconnected me. I'm back.
Oh, you were disconnected, and I was explaining. I did not know
No,
that.
I heard most of it.
So I was just saying that I hired a coach, and the coach increased my speed. Okay, because I was a runner. I was telling you that I was a runner, and at that time, in every month, I used to run approximately 10 kilometers. The mean of the distance is exactly 10 kilometers. But when
Yeah.
I hired a coach, so some of the days I'm just more than 10 kilometer, and some of the days I was just less than 10 kilometer. But now overall average is exactly greater than 10 kilometer. That is my alternate hypothesis, which I'm exactly testing. Okay, that
Yeah.
by hiring a coach, this distance is increased or not. That is known as the upper tail test. Okay, for so in this case, when we are talking about a critical region, the critical things, so this is exactly the original, and this is my claim. Okay,
How
and
do you
in
know whether it's before or after the critical region?
sorry, beta,
How do you know if it's before or after the critical region?
it will be depending on the question, na? Because whatever the question is, how they are asking in the question, like they will be telling you, na, overall average of the month is increased after hiring a coach. The overall average mean was increased from 10 kilometer. So if they are telling me that increase, so it means they are talking about the greater than.
So if
And
it
it,
was the alternative hypothesis
Mhm.
was that the mean is less than 10 kilometers, it would be the other way around.
Yeah, other way around. If you're talking about less than, na? If you're
Yeah.
talking about, yeah, it will be this one.
Okay.
Okay. So this is my claim over here, and this is my original value that we are talking about. So now, what is the basic thing which I'm just telling you? There is your test value. Whatever the test value is, there will be a test value for yourself, because when you are just figuring it out, na, so maybe the test value is right living over here, or maybe the test value is over here. Okay, but when the test value is lying in this region of the critical region, so at that time your claim will accept. Okay, and you will say that H alternate is accepted. And the other thing that you can say, that is H null is rejected. Is that clear? But
That's if it falls in the critical region.
yeah, when the test value is just lying in this critical region, okay, or when the test value is just lying before the critical region, means it is not in the critical region right now. So what I can say, that my null hypothesis is
Correct.
accepted,
Yeah.
or other way I can say that my alternate hypothesis is rejected.
And then you say there's not enough sufficient evidence or something.
Yeah, exactly. When we do not have the sufficient evidence, so we will say that H alternate is rejected and H null is accepted. And there are some particular things that you should know, which is exactly, for example, your test was claiming the test value was this one, and I was checking on the probability of 5%. So if this is less than 5%, less than 5% means what? Do you know that less than 5% means like it is lying in this portion? Okay, because if it is
Why
a
would it lie in that portion? Wouldn't it lie on the left?
no, it will not like this. Just let me know. Let me know one thing. I'm asking you. Let's suppose if you are having a normal, na? So normal is always looks like this. So when they are talking about a 5%, na beta. So let's suppose this is the 5%. Okay, this portion is known as exactly 5%. Give me a second. So this portion is considered as the 5%. But let's suppose if I'm talking to you like this. For example, your test value is less than 5%, so it means it must be 3%, something like that. Hmm? So in order to get 3%, how will you draw your normal distribution chart? It will be look like this, Navita. This portion is exactly 5%, and over here, when it is less than 5%, so it means 3% will be in this portion, isn't it?
Yeah.
So it is known that when the test value, when you are just testing, when whatever the test value you are just testing, if the probability it is less than the probability of this 5%, na, so it means you are just claiming that your critical region, or you are claiming that your alternate hypothesis is accepted. Okay, and when it is greater than that one, na, so at that time you will be saying that H null hypothesis is accepted. So I'm writing it over here for you, like it was just explaining. So this particular thing is exactly for your claim, and probability x greater than test value when it is greater than 5%. So at that time I am saying that my null hypothesis will be accepted. Is that clear?
Yeah.
Okay. And what about the two tail? For example, like we should understand a two tail na, by the question. I have a question right over here with me. The question is probability of red cars in an
Oh yeah,
area.
whenever it's two tail, I never know what's except and like what's the exception region and what's the rejection region.
Okay, just let me then let me explain it all the stuff to you. Then after that I will just go. So then this portion is exactly for the upper tail, na? So what will be with the lower tail? Lower tail test will be dealing with you it's a lower tail. Okay. Now I am dealing with the other portion.
Yeah.
The same thing. I will go with it. Now my claim is my mu is exactly less than 10, and the critical region will be changed over here. It's your claim, and it's your original value, like it is 10 or something like that. And that must be checking on, for example, it is a larger region na, so I cannot say that it's a 5%. It must be something like that, just for understanding. I should make it like this, because most of the time it will be 5% or 6%. So just unconditional thing which I'm just, it's a 5%. So this portion is my exactly claim, and this portion is exactly my original and this diagram should be like this. So in this area, you know that your test value, if the test value is lying over here, that is your test value. And this portion is exactly for the test value. So over here, H null is accepted, and in this portion, H alternative is accepted. Okay. And when I'm dealing with the two-tailed test, are you writing it?
Yeah, but I'm done anyway.
Done it. Okay. So when you are dealing with the two-tailed test, so at that time there are two possibilities. Now, let's suppose they are saying you they are going to test at a 5%. Okay, your alpha is exactly 5%. So what will be happening? Like as we have discussed about the confidence interval like this, the in the estimation, sampling and estimation. So if they are testing it on 5%, so in that case, this 0.05 will be dividing by 2 and it will become 0.025, which is exactly 2.5%. Okay.
Yeah.
So in this case, this portion, which is over here, and this portion, which is over here. So what you can say, like this region will be satisfying your null hypothesis, and this both the regions will be satisfying your alternate hypothesis. And this is exactly both of them are 5%, and exactly this is 2.5%, and it is exactly 2.5%. Got it? And in this portion, this length will be representing 2.5%, and this length will be representing 2.5%. So in this case, what I'm just going to test, like for example, this area, na, this is my claiming area, and this is my claim, and this portion is recommending my original one, And how the question will be look like in this case, they would be saying that your average monthly was exactly 10 kilometers, but the other thing, the alternate hypothesis, they do not know what it is. It is greater than or less than. So they will say that your average your average monthly run distance is not equal to 10. So not equal to 10 means maybe we are having two different possibilities. Like it can be lying less than 10 or it can be greater than 10. Okay. So this portion of the test value will be considering as my 10, and this portion will be considering my claim that it is less than 10 and this is greater than 10. So it can be lying anywhere. So when the original portion is talking about, it is going to be H null is accepted, and that will be H alternative, and that is exactly H alternative. Okay. Okay, beta.
Yeah.
Now we can discuss the question. And it is a random question which I am just discussing about, just testing the hypothesis. I did not told you about the rules and how to write and what are the steps of writing. I did not tell it right now.
Yeah. Okay.
Probability of red cars. Probability of red cars in an area is 0.2, like it's a probability. Ali, stick Ali. Ali claims that the red cars have reduced recently out of 15 cars, 2 were red. Use significance level of 10%. Okay,
Yeah.
so this assumption is look like that. For example, whatever the data is given, it's look like the binomial, isn't it? Because
Yeah.
this is a probability of success, and there will be a failure. There is n, and the test value is 2. So this is exactly n of binomial. This is your probability of success, and this is your test value. Okay. So what you will do when you are going for the hypothesis, you will proceed the questions like this. Like H null will be like exactly probability is 0.2, and at that case H alternative will be probability will be, because they have told you about the thing, na? They have mentioned you something like the red cards have reduced
Yeah.
recently. So it means we are going to test it like less than 0.2. Okay.
Yeah.
So it will be considered as the lower tail test right over here. And furthermore, when we are going to discuss it, this is 0 and this is exactly total of 15, and my test C is over here. So this portion, no, will be considered as 10%. Okay.
Yeah.
So when we are having the probability with less than 0.2, so in that case we can say that it will be considered in this portion. Okay.
Yeah.
By I was just mentioning you how to figure it out from the question. Okay. I was not exactly calculating.
Okay.
And the two tail question will be look like this. Mean length of nails is exactly 8 centimeter, it is claimed that this is now,
Wait, why are we not finishing the calculation though?
because calculation needs some more important points as well, na? So that's why I did
Okay.
not calculate it. I just mentioning you the questions exactly first.
Yeah, but what would we do for this? Find the Z value for 10%?
No, it's a binomial, na? You will just lead out the probabilities for that thing.
Okay.
This is the formula for the binomial. Do you remember that? X follows binomial distribution with n and p.
And then you do
NC.
NC4, yeah.
Yeah, exactly. Px and q to the power n minus x. Okay.
But what would you put as N and what would you put as X?
N will be better 15, C2, and probability will be 0.2, and x is exactly 2, and failure will be 0.8, and that is exactly 15 minus 2.
So I do probability of 2, 1, and 0?
Yeah, no, only 2. Exactly 2. They were not
Oh,
telling you.
okay.
Exactly 2. I forgot the question. Shit. What was that? Mean length of a nail is 8 centimeter. It is claimed that this is now changed in a sample of 8 nails. Mean is found to be 7.1 carry out a 5% level of significance. So this is the two-tailed test, no? Isn't it? Because they were telling you mean length of a nail is 8 centimeter. It is claimed that this is now changed, but they did not mention it. Did they
Yeah.
mention it? They did
No.
not mention that is a greater than or less than. So this kind of question will be treating you like the two-tailed test. So over here, there will be, it is a 5%. So it means 2.5 or 2.5 on both the sides. No? So 0 to n, this is your critical region, and that will be leading you to the percentage of, this is exactly 2.5%, and this is also exactly 2.5%. Okay, and this portion will be H acceptance, and this is for the alternate acceptance and alternate acceptance. Okay,
Yeah.
and over here there are two conditions, na, which is to be, you know that I have wrote it to you, na, like when it is less than and when it is not less than.
What do you mean?
Did I mention that one? Okay. The probabilities. No, I did not mention it. In this area, the x greater than test value, it must be less than 2.5% in this region, or in this region, it is also this one, the same. X greater than test value is less than 2.5%. Okay. Now you have understood how to figure out the question, so we can proceed with the steps of carrying the test.
Didn't you write the exact same thing for both?
Yeah, I wrote the exact same thing.
But then how do you know, like, I'm confused about this probability thing you wrote.
So this portion will be like this one, no? Like this null hypothesis at a time. It will be test value will be greater than 2.5%. So this is the portion which is exactly greater than 2.5%, no?
So if the probability I find less than 2.5, it falls
So it will
between
be,
them.
yeah, definitely it will be lying over here. But when you got the probability which is greater than 2.5%, so at that time it will be considering as a null hypothesis, no? Okay.
Yeah.
Steps to carry out the hypothesis. So the first step is exactly define variable and as well as distribution. So for example, just like that, now your x is following this. Just a second. Your x follows a binomial distribution just like 20 and then something like the value, whatever the probability or something. Okay. Second step is this. State the hypothesis. So hypothesis will be like this. Let's suppose it is the probability n, and I'm writing it just like that. It's 2.0.25. So we can proceed with this one like alternate null hypothesis is a probability which is exactly 0.25, or alternate hypothesis. It can be anything, but I'm just considering it greater than 0.25. Okay. And the third step, these are the steps which you have to follow for just getting a full marks. Okay.
Yeah.
And this is your original and this is your claim. And the third most important step is exactly state the distribution according to null hypothesis. Okay.
Yeah.
So for example, x follows the binomial distribution that was 20 and 0.25 or something like that. Value of h naught will be p. Maha, sometimes it happens that like here we already always write p because we do not know exactly the P before the state of hypothesis. And remember, in this step, we say that value of H naught will always be probability of success. Okay.
Value of what? Oh, okay.
And fourth step is exactly level of significance or type of test. Both the things will be defined in the fourth step. So, for example, alpha percent was the level of significance. So, alternate can be tested in this way. Like, it's if it is a greater than, so it will be known as upper tail, and lesser than, it will be known as lower tail, or not equal to, it's going to be two tail. And in the fourth step, sorry, fifth step, state the rejected region, or you can write exactly critical region. Okay.
Yeah.
And for writing the critical region, it is exactly look like that, na? Which I have mentioned you over here. This kind of things. This is okay.
Yeah.
And in the sixth step, check probability with test value, which is exactly the computation you call it. Okay. You called it a computation or calculation. Okay, beta. In this step,
Yeah.
you will go for the calculation. And in the seventh step, you will go for the conclusion, which is exactly your decision. That either you are going to accept the H null hypothesis or H alternate hypothesis. Okay, beta.
Yeah.
Is it fine up till now?
Yeah.
Okay. So there are some important things that you should remember for the calculation I'm telling you. There will be two type of things we will be following. First one is discrete, and second one is continuous. In discrete, we always go with binomial and Poisson. Okay, and in continuous, we go with it the normal. Okay,
Yeah.
so when I go with it now, like when I am dealing with the discrete, so at that time the method which I use, which is exactly trial and error.
What do you mean trial and error?
Trial and error means like I have to check the conditions, because for example, let me tell you, like what I'm just going to test, it is exactly between the values, which is critical value, and I am checking my hypothesis in this way. this portion is exactly my 5% level of significance, and my critical checking is exactly, for example, let's suppose take some values now, like x is greater than equal to 7 and x is greater than equal to 4. 7, 7 8. Hmm, that is exactly 8. Okay, so I'm considering it's from 0 to 20. Now see this. I will check the probabilities by the rule of the checking. Means hit and trial means you have to check it by the calculation again and again, or you will just go for the cumulative table. Okay, cumulative values by the calculator as well, na? When you are dealing with the binomial or Poisson distribution, because there is a table for table in MF19 for the cumulative probabilities, na? So this is the cumulative probability, you will figure it out. So let's suppose when you test your value at 7, na? X greater than 7, x greater than 7, you need to get the values of n and the probability of success at that time. So when you check that one, so you got 10% probability over here, and at 8 you got exactly 4% probability. So it means your 8 must be lying in this region, and this region will be considering with 7, because this probability which is exactly less than this 5%, isn't it? This 8 one. Okay.
Yeah.
uh, so
Sorry, this is lagging.
no issue. So in this area, we can say that in this critical region, the value of x can be 8, 9, 10, and so on up till 20. And in this region, we can say that x will be 0, 1, 2, and up till 7. Okay. And over here, we can say h naught 1. And in this region, we can say h alternate will win. Okay. But when we are dealing with the continuous distribution na, at that time, so the continuous is totally different. It can be proceed with the calculation of directly, we can figure it out, no, by the normal, because there are three type of tests that we do. Upper tail, lower tail, and so this is 5%. In the lower tail, it is exactly, this is the critical region, so this is 5%. And two tail, 2.5%, and 2.5%. Have you wrote it?
Yeah.
So when you go with types of question, so it can be just a second. X follows if it is a binomial. X follows a binomial distribution with P probability with X equal to R, which can be seen by NCR P to the power R and Q to the power N minus R. And the other way around, we will have normal approximation to binomial distribution. So the conditions for this one is very important. The conditions are like if your NP it's greater than 5 or NQ it's greater than 5. So at that time you will proceed with this one. The first thing you know that the mean should be NP and your variance should be under root of NPQ. And the third thing is correction of continuity. You know about the correction of continuity, na?
Yeah.
When it is exactly Poisson distribution. So at that time we will go with it. Like X follows a Poisson distribution with lambda and Px equal to R, which is exactly exponential minus lambda and lambda to the power R divided by R factorial.
So
And
this is changing normal to binomial?
yes,
But why would you do that?
we have to do that because of the calculations. No? They were giving the probability of success at that time. So how can we proceed with that normal now? Because there is no conditions for the mean, something like that values. Poisson approximation to binomial distribution. Did you study that thing?
Correct.
Poisson to there is the same thing. Like there is just important conditions. N is greater than 50 and probability is less than 0.1. If these two conditions are fulfilling, na, so we convert the Poisson distribution to binomial. Okay.
Yeah.
So at that time mu will be NP, which is equal to lambda, and your variance is exactly NPQ, which is exactly lambda. Or over here there is no continuity correction. And when we are having normal approximation to Poisson, Poisson distribution. So the condition for that one is exactly, oh sorry, Poisson to normal approximation. So at the time the condition is lambda is greater than 15 and mu will be lambda and variance standard deviation will be under root of lambda, or there will be continuity correction. Are you writing it, beta?
Yeah, I'm on the top one.
Top one.
Yeah. Wait, can you scroll down a bit? Okay, I'm done.
Okay, now the errors, no? Type 1 error, type 2 error. So when we are dealing with the errors now, so the factors which is very important at that time, which are impacting on that errors, the data must be biased, whatever is provided. And second thing is probability model not correct, and alpha percent significance level is not appropriate. There are two type of error. Type 1 error and type 2 error. So type 1 error is exactly the thing that H naught is rejected. Okay. So just let's suppose you are talking about a biased dice or something like that. Now I can just give you an example. Uh, Roll a dice and roll a dice. Wait, that H naught was at that time probability was equal to 1 by 6, and H alternative was probability must be greater than 1 by 6. And if it is a biased dice, na, the dice was biased. So that is not possible that the probability should be greater than that one, isn't it?
Yeah.
So at that time, what happened? Your calculation was lying in this region, and according to that region, you just say that H naught is rejected. Okay,
But what does type 1 like mean?
type one means like H naught should be accepted, but unfortunately, it was rejected because of the calculations. Okay,
But in what situation would that happen?
sorry.
In what situation would that happen?
The situation is just like that. Now we are dealing with the unbiased dice. Okay, so every landed probability should be 1 by 6, isn't it? But we
Yeah.
calculate, and the probability was greater than 1 by 6. So
Mm-hmm.
it means it's calculation error, na? It cannot be happen. So at that time, according to the calculation, I said that S naught should be rejected. Okay, that is a type 1 error. Got it?
Yeah.
And the type 2 error is false H naught is accepted. Okay. So that was unbiased die. And over here I again roll a die, and that was a biased. Okay. So my hypothesis was probability was 1 upon 6, and alternate was probability is greater than 1 upon 6. And do you know what happened? I just accepted that H naught, because on the biased die, na, it is not accepted. it is not possible that every phase will be having the 1 upon 6 probability, isn't it?
Yeah.
So it means we can say that H naught should not be accepted now, but false H naught was there, and according to my calculation, I was getting the probability 1 by 6, and I accept my H naught.
Okay.
Okay, this is exactly type 1 error and type 2 error. And on the regions, if I'm dealing with the regions, I must be needing 3 diagrams for that. So if it was upper tail test, so upper tail test means like this portion will be your type 1 error. Okay, because in type 1 we say that H naught is rejected,
Yeah.
and this is your type 2 error. And in the lower tail test, this is a type 1 and this is a type 2. And in the two tail test, we say that this is type 1 and this is type 1. Hmm. So this is exactly the conditions for that one. Huh? And the one last thing, I'm just mentioning it, writing it over here. Just a second, but happened? So did you get it? Like in actual, H naught was true. Okay, and over here we accept the H naught. So that is a correct decision. Okay.
But I don't. The part that I don't get is what type one. How is type one like you rejected it, but HO is still true? Like it doesn't make sense to me.
No, 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 no. I am telling you that, for example, your H naught was true. Okay, they were talking about just example. Na? This example, when I gave you an example of unbiased. Okay, so but the calculation, I was just tossing a coin and I was getting the probability of 1 by 6 of every phase. That is true. But in my calculation, I got the probability which is greater than 1 by 6. So in that case, what we will do, according to the conclusion, we will say that H naught should be rejected, isn't it?
Yeah.
So in this case, the H naught was true, but we rejected because of the calculation. That was a wrong decision, and it is known as type 1 error. Okay.
Okay.
And second thing, what we did, like I was dealing with the bias dice. Okay. So bias dice will not be having every phase will be not be having a probability of 1 by 6, isn't it?
Mhm.
So at that time, we accept that the H naught was false. Okay, and we what we did, we accept that H naught. So that will be a wrong decision, na? Because we accepted the false H naught. Every phase cannot have the probability of 1 by 6 on the biased dice.
Okay.
So the correct decision should be this one. Like we reject the H naught. So this is the last thing of that theoretical chapter. Na? Now we can proceed with the questions in the next class. So let me know tomorrow's availability. Did you make that one or did you make the chart?
No, but can you send this to me as well?
Yeah, I can send this to you as well. What was the email address? I guess this one, MS Shazad.
Yeah.
Okay.
Okay.
Okay, then see you tomorrow. And let me know your availability. Na? I am available. I have told you which timings.
You 7 to 8, you said, right?
Yeah, 7 to 8 will be fine for me. Very good.
Okay, I'll let you know.
Okay, sure. Take care,
Allah
Allah
Hafiz.
Hafiz.